Here for another talk for the Cloud and DevOps Fest. So again, welcome everyone. Thank you for your time. Uh, and yeah, it's great to have you all here. Today we have Francisco Barquero, who is going to present the topic alternatives to manage sensitive data in Kubernetes. Francisco is a QA architect here at the Gap and has been working in the tech industry for over 15 years now, with 10 of those years here at Gap. So, sorry, he's very passionate about technology, especially cloud-related technologies, with a big love for Kubernetes and containers. This passion led him to the path of cloud computing, and he aspires to become a Kubernetes one day. So, how do you say that, Francisco? Sorry.
It is a Cubastronaut.
Cubastronaut. Okay,
Yeah.
Cubastronaut. All right. Welcome, Francisco. The stage is all yours. Go ahead.
Thank you very much. So first of all, I'm very thankful for having you all here. The talk is going to be a little bit technical, well, like 80% technical. So most of the presentation is going to be console. We are going to throw a lot of Kubernetes, a lot of command lines, and a lot of pretty cool stuff. So I'll start sharing my screen. And please let me know when you guys can see it.
There is.
All right. So the plan that I had for today is basically talked about some alternatives to manage sensitive data, knowing sensitive data as secrets in Kubernetes. So I started going a little bit more deep into the part of secrets because I was studying quite a bit ago GitOps. And when I was trying to apply GitOps, I found the challenge of what do I do with my secrets, right? So what do I do with my sensitive data? What do I do with my configurations for my database, for my API keys, and all that good stuff? So um, doing a little bit of research, I came with several solutions. Two of them capture my attention quite a bit. One of those is Bitnami Seal Secrets, and the other one is Secret Store CSI driver. So the talk is going to be mostly AWS related. However, everything that we are going to see today can be applied to any Kubernetes cluster in general. So if you have well, most of the solutions, even if you have the Kubernetes cluster on premise, for example, a in a home node or something like that. For the secret stored CSI driver, that's a cloud associated a cloud associated solution. So we'll see that implemented in AWS. So the agenda, as a brief introduction, we are going to talk about Kubernetes secrets, the challenges of Kubernetes and code repositories. And then after, we are going to talk about Bitnami Seal Secrets and Secret Store CSI driver. So the technology stack that we are going to see today, it's going to be AWS AKS. That's a managed Kubernetes service that AWS provide. We are going to use Helm to install some drivers. Well, in that case, the CSI driver and also the Bitnami Seal secret controller. And besides that, we will be using a little bit of kubectl console and the Kubernetes manifest in general. That's just to give you a overview of it. We are not going to go deep into Helm charts. We are going to use them to install things in the cluster. So secrets in Kubernetes, understanding the basics. Basically, a secret is an object in the Kubernetes world that enable us to put sensitive data into our cluster and make it available for the pods that we are going to spin up in order to inject those secrets or those sensitive data like credentials or string connections, Docker connections, or things like that, Docker credentials into the pods. So one of the caveats of the problems I will say that secrets have is that when we deploy the secret and when we create the secret, the content of the secret is not encrypted. It is in code base 64. Nevertheless, base 64 you can decode it in the console, so it is not that quite secure. So you cannot push the secrets into a code repository, right? So that was one of the main challenges I found, and that of the main challenges I've seen in the implementation of Kubernetes clusters in my experience. Um, so we are going to see how a secret works for those who has no that much experience with Kubernetes and the clusters and the secrets in general. So what we are going to do is that I'm going to open the Visual Studio Code for a second, and I'm going to open which is basically the structure of a secret, right? So if we see here, this is a manifest that defines the secret object. We will see that we have the kind, which is the secret, and the type of secret that we are going to create. In this case, we are going to basically create an opaque secret, which is going to have my secret as a key, and this is going to be the value of the secret, right? So if I do apply that secret in my Kubernetes cluster, let me go to Bitnami. Now we have the secret created in the Kubernetes cluster. So if I pull all the secrets that I have in my Kubernetes cluster, I'm working on the default namespace, by the way, but all what we are going to see today applies for any namespace that you have in your Kubernetes cluster. So if I pull my secrets, CTL, we will see that we have our secret created, right? Now, if I pull the information from the secret, so if I want to decode like the secret, I'll use a command like this one, right? Which is let me move this one aside. Which is kubectl get secret. I'm going to get the secret with the secret name, and I'm going to output that as a JSON path, and I'm going to pull my secret value that we have inside, and I'm going to pipe that to base 64 decode in order to decode the value of it. So if I execute that command, we'll see that the secret is visible, right, in the command line. So if I push my secret in the pipeline or in the Git repository, anyone can copy that text and go to a Linux command line, for example, and do a echo of the value, pipe that, base 64, that's the code, and we'll see what is in there, right? So it is not secure at all. So how do we fix that? How do we mitigate that situation? How do we manage the secrets? In order to do that, we have the two alternatives that we are going to see today, which is the Bitnami seal secrets as the first option that we are going to present today. And Bitnami seal secrets or seal secrets comes to solve a problem, which is manage all the Kubernetes configs in the Git repository, right? In order to apply GitOps, you have to be able to push all that on Git and make Git your source of truth for your infrastructure that is deployed in your Kubernetes cluster. So the problem is, how do we push the secrets, right? So the solution for Bitnami seal secrets is to encrypt the secrets and and basically push them to the Git repository in a way that you cannot decrypt that if you have not the decryption key, right? So as an example of it, we are going to see a demo. Go back here, and we are going to go back to the Kubernetes cluster, and I'm going to start doing some configurations. I did prepare the configuration for the seal secrets, but I didn't install the Helm chart because I wanted just to install it on live. It's something pretty quick. So what we are going to do is that I already downloaded the Helm chart in my local computer, and I have Helm installed. So I'm going to execute the following command, which is a Helm install of the seal secrets repository. I'm going to install that in the kube system namespace, and I'm going to basically set the name of the controller as a seal secret controller in order to make kubectl, which is another tool, to interact with it in an easier way, right? So I'm going to do the installation of it. It's going to take a little bit of time. Meanwhile, it got installed already, right? So now, what do we get when we install seal secrets? So we get the controller, which is going to spin up a encryption key. There are a lot of configurations that we can perform um, on the seal secrets controller. We can specify a specific encryption key if we want to use a particular encryption key that we are creating and managing in a cloud environment. We can define the rotation of the keys. Usually, seal secrets rotates the keys that use for encryption like every month or so. So it keeps the backup of all the old keys plus the new key, and we can set up the rotation if we want to apply rotation. If we want to disable the rotation, we can do so as well. I'm not going to showcase all those examples because of time constraints, but I'm going to show you what is installed in the with the controller based on the Helm chart, and how those a encrypted secret looks like and how we consume that as well. So if I do a kubectl get pods on the namespace kube system, or TL, we will see the seal secret controller installed as a pod in my kube system namespace, which is the one that is going to provide me the ability of encrypt the secrets, but also decrypt the secrets. And it is going to install also a Kubernetes custom resource definition, which is going to help us to create the seal secrets. Now, okay, so now we have the seal, the tool. I'm going to remove this file. I'm going to make this terminal a little bit bigger. So now what we are going to do is that we are going to use a tool that works quite similar to kubectl, which is called kubectl. It comes as part of the toolset of Bitnami seal secrets. And what this tool does is that it communicates or connects to the Kubernetes cluster in order to pull the encryption key, encrypts the secret in our local environment. So we have the secret encrypted in order to push it to the Git repository and apply it in the Kubernetes cluster as well. So in order to encrypt the secret, I'm going to use the secret that I have here, which is the one that we were seeing before. And I'm going to encrypt that. So in order to encrypt that, seal, I'm going to specify the file that I want to encrypt. And I'm going to write that in a new file, right? So that is going to create a new file, which is going to have the following structure, which is the kind now is seal secret. So as default, Kubernetes has note that type of object. So the CRD uh, that install the seal secret controller is the one that is going to enable us to create the seal secret. Now, what is going to happen now is that I'm going to apply my secret into the cluster, and the cluster is going to automatically decrypt the secret. So first of all, I'm going to check if we have no secrets in the cluster. So we have one, so I'm going to remove it. So now we have no secrets. Mhm. And now what I'm going to do is I'm going to apply the secret that has been encrypted, right? So apply -f, and I'm going to apply my seal secret. So it is going to apply the seal secret as we apply any other manifest in Kubernetes. But we are going to see two different things in the cluster. The first thing is that we are going to see a secret that has been recreated with the name of secret example, which is the name that we specified here in line 6. And the second thing that we are going to see is that we have a seal secret. Seal. That is in the stage of sync. So whenever we push or we deploy or apply a secret, a encrypted seal secret, the controller is going to take that secret, is going to verify all the um, required things or parameters in order to decrypt the secret, and it is going to decrypt that secret and create a new secret in my Kubernetes cluster. So for example, if I do apply a deployment for a container, right? And I deploy that container should be able to mount the secret that I created here with seal secrets in the Git repository. So let me move this one aside and post notifications as well. So now, if I see the pods, I need to change my L in the keyword. So I have these containers. So if I connect to the container, I'm going to be able to see what's going on with my secret. So usually secrets are mounted as a environment variable that can be mounted as a file as well. We will see that in a bit. But in this case, I'm mounting the secret as a environment variable. So the name of the environment variable is my secret. So if I forgot this dollar sign, here we go. So if we see the value that is in the environment variable, it is the secret that we did push in the Kubernetes cluster with the seal secret. So what is cool about this is that if you have the secret encrypted, you can put that even in a public repository. No one is going to be able to decrypt that unless they have the encryption key, right? And also, I'm going to leave this and clean the console. Also, seal secrets is quite restrictive. So you have different levels of restrictions for the encryption in order to make your seal secret less secure or more secure. What do I mean with that? Usually, seal secret by default takes the name of the namespace where the secret is going to be deployed in order to um, encrypt or use it as a value for the encryption process. It also uses the name of the secret and the encryption key, right? So if we want to make it less restrictive and make the secret available for all the to be deployed on different namespaces, we can remove the restriction of the namespace. If we want to make it, or if we want to encrypt only the value of the secret and use this definition as a template, for example, in a Helm chart, we can do it as well. kubectl has a functionality of encrypt only portions of text, so you can send that value to the kubectl, and it is going to return you only this specific value, which is not, which can be restricted to the namespace and the name of the secret as well. Or you can play around and say, well, I want my secret to be available for all namespaces, so you can remove the restriction of namespaces as well. But this is fully encrypted. If no key, no values. Um, so that's for seal secret. That's the first option I found that I personally think is very interesting, very easy to use, very easy to implement, and very flexible in terms of configuration, right? The second option that we have is secret store CSI driver. And this one is going to take a little bit more configuration. But the good thing is that we are going to interact directly with the enterprise grade um, secret provider for the different clouds. So the problem that comes to solve this is basically something similar, almost the same as the seal secrets. I'm going to add an extra statement here, which is it comes to also try to avoid creating secrets in the first place in the Kubernetes cluster. So you will see that in the moment when I do the demo. It has the two options. We can create secrets in the Kubernetes cluster. The secret store CSI driver has the option to sync the secrets as a secret object in the Kubernetes cluster, or also it can mount the secret into the pod as a volume with the file. So we have the two options. So by mounting the file, by mounting the secret as a file, we remove or we reduce a little bit the attack surface in case of having our cluster attacked by a hacker, right? But that's just one of the advantages that the secret store CSI driver offers. Um, so in a nutshell, um, is a CSI driver that allow us to connect to the different cloud providers secret store. For example, in this case, we are going to use AWS. And for AWS, we are going to use a secret manager. So I'm going to open real quick my AWS account. We'll need a second for that. And I'm going to start the configuration of it. So in order to configure CL secret, secret store CSI driver, we will use a Helm chart as well. I have my Helm chart already installed. So I'm going to move this terminal here. I'm going to go to the secrets store for AWS. So now the first thing that we are going to do, since I already have my my Helm chart repo added to my Helm, I'm going to install the chart in my cluster. I'm going to install that in the uh, kube system namespace as well. And what we are going to see is that it is going to create pods for the controller, and it is applied as a daemon set. So every node is going to have a CSI driver to connect to AWS in this case. So if I do a kubectl get pods for the namespace kube system, we will see that we have two pods basically. One for one of the nodes. I have two nodes, if I'm not mistaken. Yep, I have two nodes. So what we are going to do next is to install the AWS provider. There is a Git repository that supports the Secret Store CSI driver. They have several providers for the different clouds. Currently, the Secret Store CSI driver supports AWS, GCP, Azure, and also HashiCorp Vault. And I think they are supporting right now two other clouds, if I'm not mistaken, but I don't remember the names right now at the top of my mind. So what I'm going to do is that I'm going to install the provider for AWS, and it is going to create us a couple of things, especially the 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 provider and a class that we are going to use later on in order to create the connection in between the cluster and the AWS. Um, Another advantage that this secret store has is that we do not have to provide any credentials inside our Kubernetes cluster in order to connect to the AWS cloud. We are going to use a service account, and we are going to use IAM roles and policies in order to make it work. So the next thing I'm going to do is that I'm going to install the OCI, no, sorry, the OpenID Connect provider, so we can have the connection between the cluster and the cloud. And after that, we'll need, I'll start creating some data for testing, or some things that we can use to play around, right? So the first thing I'm going to do is that I'm going to create a secret, but that secret, I'm going to change the name because I've been playing a little bit with that, and I have some secrets that are in queue for deletion. So I'm going to create this secret, and once we create this secret, we will see in the AWS console. I go to Secret Manager, that we have the CloudFest creds 01 secret created, right? So this is the secret that we are going to consume in our pod in a moment. So if I come to retrieve the secret, we will see that we have the username CloudFest and the password aka secret value, right? So those are the values that we are going to pull to the Kubernetes cluster. Mhm. So now let's get back to the Kubernetes cluster. I'm going to back up this IRN because we are going to use it in order to give the policy the permissions to access only this secret. That's a good practice. So whenever you guys are creating policies, follow the principle of the least privilege and give permissions only to exactly what you need to provide permissions, right? Just a recommendation for studying and playing around. You can connect to all the secrets that you have in your secret manager, but for implementations is always to provide access only to what exactly you need. So now that we have the secret created, I'm going to create a policy for that secret. So I'm going to copy my IRN, modify my policy. I have a policy that is pre-built. This is going to be the policy that we are going to use. And this command, what it is going to do is that it is going to create a policy um, that we are going to associate to the service account in order to connect to the AWS environment, specifically to the secret manager. So we'll see a couple of interesting things here. The first is the action. Well, the effect is allow. The action is to access the secret manager get secret value and the describe secret. Those two are the actions that we require in order to query the secrets that we have. And the resource that we are going to query specifically is the secret that we created in the steps above, right? Um, aside from that, the command is going to output the IRN or the um, Amazon resource name in the in a environment variable, right? So we can use it in the subsequent steps. So if I create my policy and I print my environment variable, we'll see the policy IRN that we are going to use later on. So now we are going to create the service account. So the service account is kind of a robotic user that we are going to use in order to attach that user to the pod or the deployment with the pod, and to provide the pod the permissions and basically the permissions to access the AWS in a nutshell. It is going to have a lot more things behind the scenes, but for now we can keep it simple. For the management of the cluster, right now I'm using AKS-CTL. All those steps that I'm performing today can be applied also to a Terraform script or can be applied with Terraform. So if you guys want to play and try to implement all that with Terraform, be my guest. It can be done. I already did that. And but for the purpose of the demo today, I'm just wandering around the console, right? So I'm going to use AKA-CTL for easiness. And what I'm going to do is that I'm going to create the service account for my um, for my cluster. Let me check if everything is fine. Yeah, everything looks fine. So I'm going to create the service account. I'm going to use the region US East 1. The cluster is the test cluster I have. And the policy that I'm going to attach is the policy that we created before, which is having access to secrets manager to the specific secret. Um, so it is creating the service account and applying that to the cluster. It's going to take a couple of seconds. And meanwhile it is applied, um, I'm going to show you guys the um, close this one, the secret provider. So what the secret provider is going to do in this case is that it is going to define which provider we are going to use and which secret we are going to access and the object type and the object type that we are going to consume. In this case, we are going to connect to AWS. We are going to consume the CloudFest CRETS01, which is the secret that we created before. And we are going to consume the secret manager, right? So now we have the policy. Let me just go to the Cloud Console here to check on the policies. If I look for the Cloud best IAM policy is the one that we created, right? So we are in a good shape right now. So now, as we have our service account, I'm going to apply the secret provider to my cluster, so I can basically finish all the connections in between. And I'll show you the deployment of a container in a moment, in which I consume the secret in my pod as mounting it as a file. So, but first I'm going to apply this is a CRD as well that has been installed before with the provider. So if I do apply ctl apply the chef of my secret provider, it's going to create a secret provider for me. So now that we have the secret provider class created, we can start connecting everything together, right? So in order to connect everything together, we are going to use a deploy. But first, I'm going to remove the old deployed because I think I have still the deployment for the seal secret container. So let me see. Yep, I have that. I'm going to remove the deployment. It is terminating. Let's give it a moment. Oh, it is taking a lot to terminate that. And I'm going to remove also the secret they created before. So that is going to delete all the secrets. Yeah, remove the other secret. And the pod is gone. So now I'm going to go to the secret store and I'm going to apply my pod. But before applying the pod, well, I'm going to apply the pod, then after I'm going to show the manifest. So it is applying the secret. I think I forgot something. Let me see. Oh, looks like we are fine. Okay, so what this deployment is doing, we have a deployment object in this manifest, and what the deployment is doing is that it is defining that we are going to have only one replica of the pod that we are going to create. I did assign it a couple of labels for my application, which is a busy box, is a fantastic container for doing tests and playing around. And what I'm doing with my template, which is going to define the pod structure, is that I applied a service account, right? So this is the service account we created before. If I list the service accounts, we'll see that we have one service account deployed on my default namespace. So this is the service account we are going to use for this specific pod. And we are going to mount the secret as a volume, right? We are using the CSI, and we are using for the driver the secret store CSI for Kubernetes. That definition of the driver is part of the documentation of secrets store. So you can find all that information in there. We are making the volume read only. So security things, right? Always secure. Um, and we are providing the secret class, secret provider class, sorry, as the secret provider that we created before, which is this one, right? This is going to tell us that we are going to connect to AWS and that we are going to pull this secret, and we are going to pull from secret manager. So now this is the definition of my container inside the pod. We are going to use a busybox, and we are going to mount the volume that we did define before in line from 16 to 22, basically. And we are going to mount that volume in the mount slash secret store. So in order to look for our secret, we will connect to the container and look for that path, and eventually we will see the secret in the pod, well, in the container in that case. So let's see. Mm, Looks like something happened with my pod. What happened with my pod? This is interesting. Let me see what I'm missing. Okay. So for some reason, I forgot to save my file, and the secret provider class had the old secret name here, right? So let me fix that real quick. kubectl apply dash f secret provider class. So it is going to configure that, and hopefully the error is going to go away. Mhm. Now our pod is up and running. Thank God. So, okay, that's a cool thing about doing demos, you know. Something can go wrong, and Murphy's law, when something can go wrong, will go wrong. But the good thing is that we fixed that, right? So if I access my pod, let's see, TL, exec, dash IT. I'm going to use this little pod here. Oh. Okay, so now I'm in the pod, and if I go to the path that we define in the volume, which is dash mount secrets, we'll see a file that represents the secret that we have in the cloud. And if I open that, well, I'm going to cut the content of the file in the console. You'll see that we have the cloud fest and we have the password, which is aka secret value, right? So that showcase how you can pull secrets from the secret store from AWS, well, the secret manager in that case, and mount them into the container as a file. There is another option that is synchronizing um, the secret manager secrets into the cluster as a secret in Kubernetes. Exactly the same with CSI uh, secret store driver. And just to conclude the demo, we are going to change something, right? Because what happened? We have the following situation. What happens when we modify the value of the secret, right? If I go to my console and let's say that I'm going to modify, um, I'm going to go to the secret manager again. I'm going to modify my value, very creative. Now I save my secret. If I go back to my cluster and I cut the file again, you'll see the old value here, right? So we have two options to resynchronize the secret. The first one is to redeploy the container, which is something arguably we should not do in this scenario, or we can enable the option of the secret uh, the secret source ESI driver to automatically pull the secrets and synchronize them in the pod. In order to do that, it's fairly simple. So let me see if I remember how to do it actually. see. Hmm, I forgot the command. So, well, basically, in order to enable that, we have to modify the values for the control, well, for the deploy that we did in the Kubernetes cluster. So there are two options. Let me close this. Um, we can update the deployment, and there are two values that needs to be applied. Let me find the documentation of CSI driver for a second, which is enable auto sync and the retrieval interval. So let me go back to the documentation just to verify that real quick. Um, so from the documentation, um, mhm, this is the one that we have to modify when doing the deployment of the Kubernetes with the Helm chart. Sorry. So usually by default it comes as false. So whenever we apply that as true, it is going to start pulling the secret from the secret manager, in this case from AWS, and we can modify the pulling rate that we want to apply to it in seconds. For example, by default, it is 120 seconds. We can modify that to pull it as fast as you want, right? Also be careful with throttling if happens. I'm not sure if that might apply or not. Um, but yeah, so I'm going to delete the the container and recreate them in order to pull the new secret, because modifying the and redeploying the Helm chart is going to take a little bit of time, and we are almost at the time, and I want to see if everybody has questions. So I'm going to delete uh, the the container, and I'm going to recreate that in order to pull the new value. Right. Right. So this is the new one. This is the pod, and this is the new value that we are pulling from the cloud. And with that, we conclude the presentation. Let me go to see if, yeah. So that the quick summary is basically that we have those two options. We have other options as well. We have, for example, the external secrets operator. That's another cool option in order to manage secrets when working with GitOps or in a DevOps environment. So I'll recommend you all to play around with the three options The seal secrets is very easy to manage, kind of. It might be as complicated as we want, depending on all the customizations that we want to apply. Um, the secret store, we saw the power it has in order to connect to the cloud provider for the secrets, so we don't even have to have the secrets in the Git repository nor in the Kubernetes cluster. And there is the external secrets operator that I was not able to pull in the presentation because it is going to be a lot of things to digest, right? But having said that, if you guys have any questions, I will be more than happy to try to answer them. And if not, appreciate your participation.
All right. Thank you, Francisco, for all that information. So, guys, if you have any questions, you can raise your hand. I see one in the chat bot. It says, "Is that driver using Boto3 or API calls for retrieving the secrets? I will assume that having a small retrieval window may increase the cost of secrets managers in AWS based on the amount of secrets you're pulling and syncing, right?"
So it is accessing the API. I'm not sure what exactly it is using in order to access the API of AWS, if it is using Boto3, which is a Python library, or if it is using any other library. Um, for for that risk of increasing the cost, yeah, that's why we need to consider if we want to redeploy the container each time we change the secret, or if we want to establish a window of pooling that can be every 2 minutes, every 10 minutes, and so on and so forth, right? In order to avoid those cost increase.
Yeah, right. Okay, we have another question here that says, probably outside of this topic, are there any difference with ECS in terms of secret manager and other aspects?
Uh, with with ECS, you can consume the secrets in the secret manager directly by using policies and by defining some configurations in the services of ECS. As ECS is a managed service of AWS that has connection with all the AWS ecosystem. With AKS, since it is a kind of service outside of AWS, the Kubernetes cluster per se, we need to install the different providers and configurations and CRTs in order to connect to the AWS environment. Even though the AKS is a managed service, what AWS is managing is the control plane for the cluster.
All right.
But that's the main difference.
Perfect. I don't see any more questions, so and we are just in time, so just to remind everyone that we this week and next week we will have a new talks for the Cloud and DevOps Fest. So thank you everyone. Thank you Francisco for all the information and knowledge that you shared with us today, and thank you Gafters for attending this talk. Also, we want to hear your feedback so we can keep improving these events. So please fill out the form that I just sent in the chat box, so we can check it and keep improving. Thank you, everyone. Have a great day, and yeah, have a great week. Bye bye.
Thank you, guys. Have a good one.